In 4.1D, we're going to distinguish between a simple random sample from a stratified random sample or a cluster sample, and we will give advantages and disadvantages of each sampling method. So the first good sampling method we talked about, which was a very common one to use, is the SRS, or a simple random sample. And that method just involves that there's an equal opportunity of every possible scenario randomly happening if we use table D or a random number generator. So this second method actually uses the SRS, but you do it in terms of groups, or called strata, within a population. It's like you take subsamples within your population. Each subgroup is referred to as a strata. So in a stratified random sample, what you do is you first classify the population into groups of similar individuals. So maybe you want to strata by gender. So you could have one group of boys and one group of girls. Then you would choose an SRS in each stratum. At the end, combine the SRSs to form a full sample. So it's very similar to a standard SRS, but you just put things in common groups and do individual SRSs and then combine them at the end. This method is good to use when the individuals within each stratum are very similar. So if you can kind of section off your data, this may be an option. Here's another example. Let's assume that Congress wants to make changes to the Social Security program. And basically, older retired people benefit from this. Because of that, you might want to strata on age. The older individuals may have different views from younger people. So put them in similar groups and then do SRSs to each of those. Here's another example of maybe when you would do a strata versus just a standard SRS. Cell phone examples. So a growing percent of Americans are dropping the traditional landlines and using their cell phones exclusively. This definitely caused a problem for polling. Those organizations who in the past had used the landlines when randomly selected people for the polls. But since the group of people using cell phones exclusively are different than those who rely exclusively on cell phones, think about it. Definitely the younger generation is very cell phone heavy. The older generation probably is more landline heavy. If you're 60 or 70 years old, maybe you're straying away from cell phones. Because of this, they may do a stratified sample, and they would select a random sample of cell phone users in addition to a random sample of landline users. If we move into the field of agriculture, here's a cornfield example. Suppose we want to estimate the yield of a cornfield. The field is square and divided into 16 equally sized plots, so 4 rows and 4 columns, which we see right here. A river runs along the eastern edge of the field, so here we have a river. We want to take a sample of 4 plots. Use a random number generator, pick a simple random sample of 4 plots, and then place an X on the 4 plots that you chose. So for this first example, let's actually use table D of our random digits. And I am actually going to start on row 112 for this. So let's choose row 112. Now, taking a look at our plots, we have up to 2-digit plots, so everyone should be a 2-digit number. Therefore, it would be 01, 02, 03, and so forth. And we want to pick 4 plots. So let's start using our particular table here. As we go through, we're going to have, it looks like 59, 63, 66, another, it looks like 66, and then our first choice is right here. It's going to be at 04. So our first plot is 4. We're going to continue on. Remember, for designing a study, we would say no repeats because the next one is 04 again. Then we have 63. We have 47. Our next plot shows up as plot 11 right here. Now, if you continue on using the 2-digit numbers, you actually are going to have to go into row 113. Again, when you start over, don't count the 113, just go right here. And I'm going to show you that the next one is going to happen at this 3. And then the last one we're going to encounter is going to be at the 10. So I'm going to mark 3 and 10. Now in this method, what we basically did is we just chose a standard SRS of picking plots, the old method. Now let's go to the second scenario here. They want us to randomly choose one plot from each horizontal row. They want us to stratify by this one. This time I'm going to use the calculator. So to stratify by row, notice I have 1 through 4 in each of the rows. And what I'm going to do is run my sample choosing 4 times. So up here, if I go into the calculator, do random integer, I'm going to choose 1 through 4, and I want them just to pick one choice. So for this first row here, if I look at it, they've actually chosen 1. So let's go ahead and mark that for the first row. The second row, when I ran it again, I got a 3. The next was 4 and then 4. So I'm going to go on in here and then mark a 3, a 4, and a 4 for our sample, stratifying on row. Now I ran it again here a second time just to show you the answers would be different, and that's fine. As long as we're using a random method of getting it, it doesn't matter if these were the options that work for the rows or these. Now let's look at what if we stratify by column. So notice here, 1 through 4, we have the 4 different columns, and here's the river. I ran the random number generator on the calculator and got these as the appropriate plots to choose. So I'm going to choose plot 3 by column 1, 2, and 2. And those would be our method. Now the question is, which method do you think is the best method to use? Should we do a simple random sample? Should we stratify by row, or should we stratify by column? If you think about it, we do have something that's kind of in the way. We have this river. So we have the river over here on the right, which actually could impact the growth of our crops. Clearly, the first column is going to get more nutrition from this river, which will probably grow better, versus this far column may have different results. So in this case, stratifying by column is going to be a better option than stratifying by row or doing an SRS. So let's choose stratifying by column. So here's the question. It's time to harvest our crops. The numbers below are the yield for each of the 16 plots. So this is how many crops they got in each of the plots. Again, notice this first column has the most because it was more plentiful. It had more nourishment from the water. For each of the 3 samples, actually calculate the average yield. This will just be interesting, and what it should do is confirm for us that stratification by column was the most accurate method for us to use. So for our SRS, we actually ended up choosing plots 3, 4, 10, and 11. If I plot the distribution, we kind of see a lot of spread. And if I compute the mean of this, I get 90.75 as the yield in terms of our crops. Now let's compare that to the stratified by row. On the rows, we actually picked plots 1, 3, 4, and 4. If we plot these and take the mean, here's what we get. We actually see quite a bit more spread of plotting these 4 cells, and the average is 99.25. So just comparing these two, it looks like there's less variability in the simple random sample. Lastly, let's look at if we stratified by column. In those, the ones that we chose were in columns with the third, the first, the second, and the second. Now I circled those in the blue. When you plot them, you do see quite a bit of spread, but you see that they're kind of in various spots. We get a nice sample of the range of the data. When we compute the mean of those values, we actually get 71.5 for the yield. And if you look at this in terms of the shape, this is going to be more representative of somewhat of a symmetric distribution here. So what we're seeing is that stratification by the column gives us more stability and a more accurate average than using SRS or stratifying by row. Now the third method we're going to talk about is the cluster sample. The stratified random sample and the SRS can both be very good, precise methods to use. Sometimes these methods are hard to use though when the populations are large and spread out. So a third method we might use is the cluster sample. And what you do in this is you actually divide your population that you're looking at into smaller groups. Ideally, these clusters should have mirror characteristics. So you're basically making many mini populations. So you don't group by like group. For example, if I wanted to survey the high school. Now, if I don't have time to want to survey randomly throughout the high school in an SRS, maybe I want more controlled areas. What I might look at instead of the entire high school is cluster by groups or classes that might look like a mini high school. A good place for that might be an SPP, because in here we have mixed groups, we have mixed abilities. It's not grouped by grade. It's not grouped by honors courses. This might be a nice representation. So what I would do then is you would choose an SRS of the clusters. So you would randomly select which student prep periods we should focus on. And you looked at all the individuals in that cluster and you sample every single one of them. So what you do in the cluster method is you pick which clusters to actually survey, and you survey everyone in them. Now, let's say we have our 8 student preps in one day as our population, and we randomly select 3 of those. We would survey everyone in all 3 of those clusters in those 3 study halls and accumulate all of their results and look at that as our sample. Let's take a look at these 3 questions. We have a manager of a sports arena wants to learn more about the financial status of the people who are attending the NBA basketball game. He would like to give a survey to the representative sample of more than the 20,000 fans in attendance. Ticket prices for the game vary a great deal. Seats near the court cost over $100, while seats at the top rows cost about $25. The arena is divided into 30 different numbered sections from 101 to 130. Each section has a row of seats labeled with letters A that are near the court and Z that are to the top of the arena. So to give you a visual, imagine that this basketball court's in the middle. We have seats that go all the way around it. Here, for example, is section 101. And what you see, if this is the court, row A is here, then B, then C, all the way to double Z. Then we go around 102, 103. We know the folks in row A tend to pay more money, and we know the folks in row double Z pay less money. So they want us to talk about different sampling methods. And number 1, explain why it might be difficult to give the survey as a simple random sample to 200 fans. And keep in mind, the basketball game is going on. So if you assign every single seat a random number in the stadium, which you could, if there's 20,000 seats, we would do a 5-digit numbers for every single seat, and you'd pick 200. This might be difficult to do because you'd actually have to go out and track down every individual throughout the entire stadium. So basically, you'd have to identify the 200 different seats and go to them in 200 different locations. That is going to take you some time to go all around this stadium. Also, people are not always in their seats, so if you pick 200, you may not actually find those folks. So if you scrap doing an SRS, what would be a better way to take a stratified random sample? If you do stratified, would you use the lettered rows or would you use the numbered sections as the strata? So is it the rows or the sections you would strata in this case? Clearly, it would be better to look at the lettered rows, keeping in mind the different income levels. So these tickets on A cost more than double Z. So for a stratified sample, it'd be better to take the lettered rows as the strata because each row is the same distance from the court and you would only contain seats with the same ticket price. This means that the people in any strata would have to pay roughly the same amount for their ticket. Okay, the third method, in number 3, which would be a better way to take a cluster sample of fans? Should we use the lettered rows for the clusters or the number of sections? Remember, in clusters, we're trying to get the like populations, so kind of mini populations. Clearly, in this case, you would want to strata by each of these sections that you have because each is like a mini population representing all ticket values. So saying that, it would be better to take the numbered sections as the clusters because they include all different seat prices. Each section contains seats with many different ticket prices, so the people in this section would mirror the characteristics of the population as a whole. Let's look at one more example and go deeper into talking about how we actually do our SRS. Hotel on the beach. The manager of a beachfront hotel wants to survey guests in the hotel to estimate the overall customer satisfaction. The hotel has 2 towers, one older tower on the south side and one newer tower on the north. Each tower has 10 floors of standard rooms with 40 rooms per floor. So if we just imagine that scenario, this might be the south tower where we have, it says here, 10 floors with 40 rooms per floor, so the 10 floors. And then we have 2 floors of suites on the top with 20 suites, so in here a total of 40 rooms. And we have that replicated on the north tower. Now, in addition, half of the rooms in each tower face the beach, while the other half face the street. This means there are 2 towers, 10 floors of 40 rooms, in 2 towers, 2 floors of 20 rooms. There's a total of 880 rooms as a population. Now, how would we do this? Explain how to select just a simple random sample of 88 rooms. What you would do in here is number each room from 001 to 880. Use a random number generator to select 8 unique random integers, unique means no repeats, from these digits, and then use the selected rooms for the sample. So that's easily how you could do a standard SRS. Okay, part B. Explain how to select a stratified sample of 88 rooms and justify your choice of strata. Well, since customer satisfaction will vary based on the room location, that is if you're in a suite, if you're in the north side facing the ocean, or if you're in the south side facing the street, we should take a sample from each type of room, which means you kind of have to think about this a little bit. If we look at this tower here, and we notice that the 10 floors on this tower, again, there's 10 floors, there's 400 rooms here. There's also going to be 400 on this tower. Then in terms of the suites, there's going to be 40 suites here and 40 suites over there. We need to pick 88 rooms in total. So what we could do is actually take a portion. What if we take about 10% of each one? If we take 10% of the standard rooms here, that would be 40. And then when we take 10% of the other tower, that would be another 40. So we're at 40 and 40, we're at 80. We have 8 more rooms to choose. Well, there's 40 suites over here in Tower South and Tower North. If we take 10% of that, that would be 4 rooms, and the next one would be 4 rooms. That would be our 88 rooms for our sample. So how should we go about sampling from this and from this? We're going to strata basically by building and by room type. It would look something like this. You're actually going to have 8 unique strata, and this is somewhat of a complex example. But take a look here. We're first just going to focus on the primary base rooms of the South Tower. So this is the South Tower. Remember we said that there's 400 rooms in total. That's the 400 rooms. But it differs where you're facing. Are we facing the beach or the street? So what we're going to do is we have 200 rooms facing the beach. Let's actually pick an SRS of 20 of those rooms. Then we have 200 rooms facing the street. Do an SRS of that. We're going to get 20 rooms. This is going to be our 40 rooms from the South Tower of just the basic rooms, but breaking it down by where you are. We're going to do that same thing for the North Tower, and you see that being replicated right here. In the North Tower, we're going to total of the 400 rooms, but we break it by beach and street, and we're going to take 10% of each, or 20 of those SRSs. Now, what about when we switch over to the suites? Well, on the South Tower, we actually have 40 suites. 20 are on the beach side and 20 are on the street side, so we should pick 2 from each of those. We're then going to switch over to the North Tower and do the same thing. And when we do that, we'll get a total SRS of 88 rooms. We'll gather all those 88 rooms together and look at the final results. Lastly, explain why selecting 2 of the 24 different floors would not be a good way to obtain a cluster sample in this case. Well, a cluster sample is not going to be the best option for this because although it would be easy to collect the data once the floors were selected, each floor is more homogeneous than it is heterogeneous. Homogeneous means each floor is more more in common than they are different. So if you pick by floor, you're not going to get a good mini population. So that's bad for clustering. Ideally, each cluster should include all different types of floors, including the suites, and it should include the beach side and the street side. If you only selected 2 floors, it's fairly likely you would get no suites in the sample at all, and you would just have the basic rooms. So in this case, a cluster sample would not be adequate. Your strata is your best option. Now, I like this last slide because it really shows the three good sampling methods, kind of the advantages and disadvantages. The nice thing about a simple random sample is that it truly is the simplest way to actually select a sample. In this case, every individual in every possible sample has an option to be chosen, which is important. Now, the disadvantages of that, hard to actually use this when the population is really spread out over a large area. And it's also difficult to get from the population of interest because you have to move around all over. And because it's difficult to get, you may end up over or underrepresenting your current population. Now, what about a stratified random sample? In a stratified random sample, when the individuals in each strata are actually less varied than the population as a whole, it's really nice to use this. It can also give more precise information about the population than an SRS. Third thing, each strata contains similar individuals with large differences between strata. So when you have the large differences between the strata is when you should use it. There really is no chance to either over or underrepresent the data because you've strated by their like conditions. The difficulty with this or disadvantage is that it's hard to use when, again, the population is large and spread out, and it can be a little complicated to execute, as you saw when we talked about that hotel example and coming up with a scenario. Now, the cluster sample, the advantages of that is that when you're going to select groups of individuals that are actually near one another, so that makes it nice and easy. It's, like I said, it's easy and it's convenient to do. It has much variability as the population itself because you're choosing mini populations. And it just looks like the population but on a smaller scale. The difficult thing with that is that it doesn't offer any statistical advantages of better information about the population. The stratified random sample really gives you kind of that better information. This one, similar to like the SRS, you can over or underrepresent the population if the data has particular patterns in it.